Welcome back. Today we're going to be continuing our learning with modeling with polynomials. Modeling with polynomials is when we have some sort of data and we fit it to some sort of polynomial. A lot of times this happens when we don't have a reason to think that there's a specific model that would make sense. So we just throw a polynomial at it and see what happens. For a fundraiser, members of a math class decide to make and sell. Pythagoras may have been Fermat's first problem, but not his last t-shirts. Yeah, math joke, don't worry about it. They're trying to decide how many t-shirts to make and sell at a fixed price. They surveyed the level of interest in students around the school and made a scatter plots of t-shirts sold versus profits shown. So let's take a close look at this. We're going to use these questions to help us identify and analyze the graph we're looking at. So let's look at the y-intercept. Y-intercept is right there. And that means if they don't sell any t-shirts, they're still minus, that looks like minus 125 t-shirts. So no shirts sold. They'd have a debt or a loss of $125. Okay, so we better sell some shirts. If we model this data with a function, what point of the graph represents the number of t-shirts they need to sell to break even? So that's where profit is 0, which is about right here. So that looks like maybe 13 shirts. And therefore, the smallest number of t-shirts they can still make a profit would be about 14 shirts. One more than the break-even point. The maximum number of profit is the maximum of the graph. It seems to be right about here. And that looks like it's just at about 35 shirts or so. And that maximum profit is, looking like something like $275. Now, what factors affect the profit? Well, the cheaper the shirts, the more the profit. On the other hand, the cheaper the shirts, the less people would want to sell it. So it seems that in this model, the primary thing that affects profit is the number of shirts sold. What would cause the profit to start decreasing seems to be this rapid drop-off in interest after about 35, where you have what you would call inventory you can't move or dead inventory. Too much inventory. There's no point in having stuff you can't sell. What type of function does it appear that she's drawn? Well, that looks like a cubic. And the function that models the profit in terms of the number of students, well, look at that, it's a cubic, using the vertical intercept labeled on the graph to find the value of the leading coefficient, c. So if this is 0 and then 126, we can substitute 0 in for all these x's. And then our output should be 126. That actually simplifies to a fairly easy question where it's 126 times is equal to c times 9,828. If I divide both sides by 9,828, then I have c is approximately equal to 1.013. From the graph, estimate the profit if the math club sells 30 t-shirts. Well, using my handy dandy ruler, this is 25, so that would be 30. So that means a profit of about $250, which is not bad. Use your function to estimate the profit if the math club sells 30 t-shirts. Well, we'll take 30, we'll substitute it into there. So P of 30 is equal to 0.013 times 30 cubed minus 53 times 30 squared minus 236 times 30 plus 9 to, anyway, type that into handy. Minus, so that's minus 0.03. So we get that is approximately $230 and 15 cents. Which one is more accurate? Honestly, I would more be inclined to say let's take $30 and estimate it from there. It's a pretty close match, so the accuracy, I'm not sure if I would more prefer the graph, which gives a more holistic picture, than what seems like the false accuracy of the prediction of the equation. Whenever you have a model that isn't based on actual physical measurable things in a situation, always be really skeptical of the precision of the model, because it's not trying to match anything in the real world. And that's why in some ways looking at the larger picture would be a better idea. Looking forward to more conversations about polynomial models and why cubics are a really lousy way to model an epidemic in class today. See you there.